Hey guys, this is Miss Yeager. I'm going over the Graphing Quadratics quiz outline that I created and I uploaded. So this is everything that's going to be on your quadratics quiz that is Friday. So when you're watching this video, it's Thursday right now. So that means tomorrow you have a quiz, not a homework quiz, it's a real quiz. So the first thing we go over is standard form. So standard form is this ax squared plus bx plus c. So this is the very first thing we did where we found the vertex using negative b over 2a. So we did this while we were still in school. Okay, negative b over 2a. So remember, this gives you the axis of symmetry, which we call the AOS, and also gives you the x value of the vertex. Okay, so that's everything that this gives you. And things to remember that a minimum or a maximum value comes from the y value of the vertex. Okay, so after you find the vertex, the x is this, and this is the axis of symmetry, and then the y of your vertex is going to be min or max. So let me scoot this up some. So on the outline I made, I've given you an example. So given f of x equals x squared minus 8x plus 15, find the axis of symmetry and the minimum value. So this right here, I'm not telling you it's in standard form, but you have to know it's in standard form. So you have to know that I'm going to find x equals negative b over 2a. To do this, you need to do your ABCs. So I'm going to write them over here to the left. So my A is my 1. That's always with the x squared value. My B is negative 8. And my C is 18. Remember, it always goes A, B, C. So now that I have this, I can plug in what I know. So the negative sign stays. That's what this is right here. The B is negative 8 all over 2 times my A, which in this case is A1. So I'm going to do the math out, and let's see. Negative makes a positive, so that's a positive 8 over 2 times 1 is 2. 8 over 2, though, simplifies. 8 divided by 2 is a 4. So far, I have the x of my vertex, and I also have my axis of symmetry. So right off the bat, I can answer the axis of symmetry. My axis of symmetry is going to be x equals, it's always x because that's what we solved for, x equals 4. So I already have one answer. But that's not the only thing it's asking me. It's asking me also what the minimum value is. So the minimum value, I'm going to take this, and that's the x, remember. I'm going to plug it in. So you can either plug it in or use the table function in your calculator. I'm just going to plug it in. So I need the y value, which in this case is going to be a minimum. How do I know it's going to be a minimum? Well, this number out front's a 1, right? And the number out front tells me up or down. So 1 in this case is positive. So this is going to look like a smiley face. And you can put little eyes on it if you want. Okay, so that's everything I know so far. And I'm going to plug it in. So let's see, my x was 4. So everywhere there's an x, I put little parentheses. So it's almost like filling in the blanks. So plug in your 4s. Sorry guys, my cat was trying to eat my flowers. So plug in the 4. So 4 squared is 16. Minus 8 times 4 is 24, 32. Plus 15. Let's see, 16 and 15 gives me a 31. So 31 minus 32 is a negative 1. Now, if you did not want to do all that in your head, that's fine. You don't have to. You have a calculator. Okay, let's see. Okay, so this right here is my y value, which is my minimum. So my minimum value is right here. Minimum value. Okay, and on the left side, I have, what's the vertex? Well, we have everything we need. Here's the x. I already found the x, so that's 4. And I just plugged it in to find the y, which happened to also be the minimum value. So 4, -1 is the vertex. And we already answered this question. Will it open up or down? It will open up. And that is because the A value is positive. Okay, so that's everything from the first part. All standard form. Okay, the next part is intercept form. So this right here is intercept form. Okay, and that's where it looks like it's factored. So you have an A out front, whatever number that is, x minus p, or x plus p, doesn't matter, x minus q. So to find the axis of symmetry and the x of the vertex, we have a little different formula. So now you have to add your solutions together and divide by 2. You're finding the average between the two. So notice how this is a p and a q, and this is a negative p and a negative q. So when you're solving, remember, it's always going to swap signs. So I'm going to give you an example in a second. Okay, so just remember that. And it says, remember to find the y of the vertex. You can plug the x value into all the x's of the equation, like what we just did on the previous one, or plug the original equation into the table and scroll until you find that x. Okay, so you can do the same thing to find the y value of the vertex, or let's say you need the y-intercept. Same thing, you can use the table. Okay, so let me move up a little bit. So our example says, given x minus 2 and x plus 4, what is the minimum value? So look, I'm looking for a minimum value again. However, to find the minimum value, I have to first find the axis of symmetry, which I gave you up here. So the p and the q in this equation are going to be, if I solve x minus 2, and I set that equal to 0, let's write it down here. So if I say x minus 2 equals 0, then I would add 2 to both sides. So x would equal 2, right? This is previous stuff, guys. So x plus 4 equals 0 minus 4. So x would equal -4. Okay, so these are what I'm plugging into this equation up here. So I'm saying x equals 2 plus -4 divided by 2. 2 plus -4 is -2, divided by 2 is a -1. So I already got my axis of symmetry. It's not asking it from the question. However, it could, so I put it over here. So my axis of symmetry is x equals -1. Okay, but I want to know the minimum value. So that is what we just did on the other one. So I have my x, and I need to plug it into all the x's on here to find the rest of my vertex. So I want to put a little note on the side. So I have my vertex. I know it's -1 comma something. This something right here is what I'm looking for. So I'm going to take my original equation. However, instead of the x's, I'm plugging in -1 is what I'm plugging in for. Ooh, let me scroll up a little bit. So this is actually going to be -1. Oh, how about x again, y'all? This is actually going to be -1 minus 2 and -1 plus 4. -1 minus 2 is -3. If you are not sure, use your calculator, please. Times 3. -3 and 3 is a 9. So my minimum value is a 9. This right here is the minimum value. It's always going to be the y of your vertex. So if this is 9, that has to be 9. Okay. So will this open up or down? Something else you can ask yourself. Well, the A is out front. My A is a 1. I don't have to write that, but it's a 1. So my A is positive. So this will open up. The solutions are the zeros. We already found that. That's what we did right there. So your solutions would be x equals 2, x equals -4. Remember, they're always going to be the opposite signs of what originally was. So this was a negative, now it's a positive. This was a positive, now it's a negative. Okay, then there's vertex form. So when Ms. McGaw originally taught this, let's see if I can get it on here, if it'll focus. There we go. So when she originally taught this, she said to plug it into the table, which you're not wrong. I have a note at the bottom that says, if you're stuck and do not know which graph matches the function, plug it into the table in the calculator, and see which points from the table match your graph. So if you're doing multiple choice or whatever you're doing, you can always use the table function in your calculator. Okay, so it says table and then so on. So, however, vertex form gives you the vertex from the form. So automatically you know what the vertex is. So this is the form. And so the vertex is the opposite of this, keep k. So what that means, so let's just go down to our example. So this is our example right here, -2, x plus 4 squared minus 8. The vertex, this is a 4, so it's the opposite of this. It's opposite, keep. Opposite, keep. So my vertex is going to be a -4, because that's the opposite of 4, and keep the -8. Done. That's the shortcut way to figure out the vertex. If you're not sure if you're correct, when you plug into your table, you can check. Okay, which means my axis of symmetry, remember, this is the x value of the vertex, and it's always x equals, because it's an x value. Okay, so it's always the same. Is this going to open up or down? You're looking right here. So it's a negative, and when you're negative to somebody, it makes them sad. So let me move a little bit. So when you're negative to somebody, it makes them sad. So which way is this going to open? It's going to open down. It's going to look something like that. If you want to put little eyes on it. You're making them cry. Okay. Then we already know the min or max. Well, first of all, it's opening down. So this right here is a hill. So hills have maximums, and the value is always the y value from your vertex, -8. And last but not least, we need to find the y-intercept. So I'm going to grab my calculator real quick, plug this into the table. Can y'all see mine? Yeah, you can. Okay. So table, oh, you can't see where I said that. So table, I have stuff in here, so let me exit out. My function is -2 parentheses x plus 4 parentheses squared minus 8. Enter. That's fine. Enter, 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 enter. So I need to know the y-intercept. So the y-intercept is wherever your x is 0. It's always going to be 0, comma, a number. So in this case, it's 0, -40. Okay, also, I just made this up, so that's why it's so big. Okay, so 0, -40. I have one more thing to talk to you about, but I'm going to put that on the next video, so hold tight.